Hi everyone, welcome back to my channel. So, if you are new to my channel, please consider subscribing my channel. And without further ado, let's start today's session. So, in today's session, I'm going to give you one more example on module and module instantiation. So, I have already explained about what is module and what is module instantiation with the example. Okay, so if you didn't listen to that particular class, so I link that particular class description in the description box. uh, Please first go through that, and after listening to that, then come to this second example. Okay, so in the previous example, we have talked about full adder using two half adders, how the module instantiation is done in that particular example. Okay, so in this we are going to see about another example like how the module instantiation generally, where do we use this module instantiation um, in this thing. Okay, so in this particular example, first I want to design a 4 by 1 mux. Okay, so you are asked to design a 4 by 1 mux using 2 by 1 muxes. So since you already know, you want to design a 4 by 1 mux by using 2 by 1 muxes. So how many 2 by 1 muxes you need? Basically, since it's a 4 by 1 mux, you need two 2 by 1 muxes, right? And then combining those two, you again need one more 2 by 1 mux. So this is how the designing, basically the groundwork of the designing. That means when you want to design a 4 by 1 mux, you need three 2 by 1 muxes in order to design one 4 by 1 mux. Okay, so this is about it. And so first let us see how you are going to design a 2 by 1 mux. Okay, so what does the 2 by 1 mux consist of? Basically two inputs, one selection line and one output, right? So this is the truth table of the 2 by 1 mux. That means when selection line is 0, I naught will be used given as output, and if selection line is 1, then I1 will be given as output, right? So for this, first we'll be writing the Verilog code. Okay, so see, module. Okay, everything should be written within module and end module. So module and end module. Okay, so after module, you will be writing any individual name, since this is a 2 by 1 mux. So that, and also one more thing is, when you are presenting the code or when you are writing the code, you should write the, generally when you see in any examples or when you go to any websites and when you check for examples, basically they will be giving like this mux 2 1 and all. Why? Because whenever anyone refers to your code, not only you, because any code, or else whenever you are working in some like industry or something, so basically your code is not yours. Your code will be reference for many other persons, is it or not? Okay, because you are not the only one who will be working there, or you are not the only one who will be designing everything. So basically for this thing, in this type, in this things, basically what we do is, we will be naming the module based on the design that we are going to design, or based on something, by referring something, you will be keeping the name. Don't just give the random names, so that only you could understand it. Okay, and it is also not a professional way in writing the code. Got my point? So module mux 1. Okay, and then what are the inputs here? I naught and I1. So input I naught I1, and then selection line SCL. Okay, so these three are the inputs. You can either write it like this, or you can write like input select and I naught and I1 here itself. Okay, you don't need to again categorize this input select and input I naught I1. Okay, you can write everything here. But as I told you, is the professional way of writing, clean way of writing the code, by categorizing everything in the thing itself. Like selection, since this is a 2 by 1 mux, basically you'll be having one selection line only. For example, if you are designing some 8 by 1 mux and all, you'll be having more selection lines. So by categorizing all selection lines in one place and all inputs in one place, it will be pleased to see. That's it. Okay, and then output y. Okay, and then bracket close, ended with the semicolon. Clear? And then some logic. Okay, and then n module. So module and module. So this is your 2 by 1 mux code. Now you don't want to design the 2 by 1 mux code. What you want to design? You want to design the 4 by 1 mux code. So how are you going to design it? Okay, so see. So this is my 2 by 1 mux code. Okay, this is the same thing. This, okay, I have just copied it here. See, module mux 2 by 1 input selection. Okay, so this is my parent module. If you see here, why is this a parent module? Basically, this is the by using this module you will be designing your entire 4 by 1 mux. So this is the 4 by 1 mux. Okay, so see, using 2 by 1 muxes. Okay, this is my first mux, this is my second mux, and this is my third mux. So for everything, selection 1, selection of 1, that means you are having two things here, like selection 0 and selection 1. Okay, so see here, module, this is my first 2 by 1 mux, and then now I am going to write the 4 by 1 mux. So if you see here, 4 by 1 mux module mux 4 by 1, and in this, what are the input lines? Selection 0 and selection 1. Selection of 1. So here selection of 1 means nothing but selection 0 and selection 1. Okay, of 1. Okay, you'll be seeing this later, but this is nothing but a vector representation. Okay, in this vector representation, selection of 1 means selection 0 and selection 1. So selection 0 and selection 1, and then what else? Input. What are the inputs here? I0, I1, I2 and I3. So I0, I1, I2, I3, and then what is the output here? Only this is the output. And then what is this wire? Okay, just ignore this as for now, but just see here, intermediate connections. Here you are having two intermediate connections like Y0 and Y1. So these two intermediate connections will be indicated here with the data type called wire. Okay, you will see what is wire and all in the further sessions. So as for now, how we are going to connect everything? Okay, how you are going to write everything in your code? This is how you will be going to write. Got my point? And then what you are going to do? You are going to use this entire code, because you are using, this is my first mux, this is my second mux, and this is my third mux. So what are you going to do? Since you are having a 2 by 1 mux, okay, 2 by 1 mux module, so what you are going to do? You are going to make 3 active copies for this. So how is this 3 active copies means? 3 active copies means here you are using, see, mux 2 by 1, this is my name of this, mux 2 by 1 m1. Okay, and then ports connection. Okay, what are the ports that are connected here? If you see here, selection 1. Okay, selection 1, I2, I3, Y1. So this is how. In the same way, mux M2. This is another copy with these names. This is third copy with these names. And then this is how the instantiation. So if you see here, these three are nothing but module instantiations. This is how you are instantiating. That means here if you are giving this code, you are writing this thing, means what is happening means this entire code is copied here and placed. So instead of writing, so if you see here, how many lines is this? Like 1 2 3 4 5 6 5. Okay, let us think it's 5. So instead of writing all these 5 lines in everything, you can just make a copy by using a single line. That is called reusing. Okay, what you are doing, you are using this entire code, you are reusing it here. Got my point here? So this is how the module instantiation is taking place. Okay, so this is the example of module instantiation.